Let's talk about my personal favorite subject, organic chemistry, which is part of Module 8. So organic compounds are really at the heart of what's on Earth. Okay, if you look at just 4 elements in the periodic table, okay, carbon, hydrogen, nitrogen, oxygen, this makes up something like 95% of the Earth's living things. And if you throw in phosphorus and sulfur, now you're talking 99% of the stuff on Earth. Okay, and so of those different elements, carbon is really the most important one, at least in a lot of people's opinions. Carbon is king. Carbon is optimized because it's so small that it can make lots of bonds to other things, and because it can have 4 valence electrons, it can make up to 4 bonds with other things. And so there's a whole field of study called organic chemistry. We're not going to do that, but at least what I'm going to do is introduce organic chemistry to you by telling you about different functional groups. So a functional group is nothing more than a collection of certain atoms that confer certain chemical and maybe biological or maybe physical properties on these different substances. So let me show you what these different functional groups might be. We're going to start with something that is really simple and not even a functional group to begin with, but just a plain alkane. Okay, and so there are different kinds of hydrocarbons, which, as the name implies, just contain hydrogen and carbon in them. Alkanes are the simplest organic molecules. These are sometimes called saturated hydrocarbons because they have the maximum number of hydrogens for a certain number of carbons. And there's actually a formula that I can use to calculate what the formula of an alkane is going to be. Okay, so the general formula for an alkane is CnH2n plus 2. So for example, if I only have 1 carbon, then the formula for the alkane is CH4. But if I have 2 carbons, then this becomes C2H6, etc. One of the interesting things about organic compounds is they can exist in different isomeric forms, which are called constitutional isomers. So constitutional isomers have the same exact chemical formula, but different structural formulas, which means that the bonds are in different places, right? The atoms are connected in different ways to each other. And so even though they have the same formula, they can be very diverse from each other. Okay, here's an example of this. Here are 2 compounds with the same molecular formula, C4H10. Now the one on the left is called butane. And this has all 4 C's in a row, right? Here's one, here's another, and here's another. And they're all connected to each other in a straight line. But I can have something called isobutane, which is an isomer of butane, where I actually have 3 C's in a row. And then the 4th carbon, instead of being connected to the 3rd carbon, is actually right here in the middle, okay? And so now I have different connections, different bonds in different places. And so butane and isobutane, even though they have the same formula, have different properties, okay? So you have to be careful when you're using just molecular formulas to know what kind of compound you're dealing with. And as the molecules get bigger and bigger, the number of isomers just increases dramatically. Okay, so now let's talk about these different functional groups. Okay, we saw alkanes that just have carbon-carbon single bonds in them. Alkenes with an E have a double bond in them. Alkynes with a Y have a triple bond in them. There's also something called an arene, although most people don't call it an arene, but just call it an aromatic ring. That's this benzene ring, okay? So all of these are still considered hydrocarbons because they only contain hydrogen and carbon in them. But there are other elements in the periodic table. So for example, if you have a halogen in your substance, we call these things halides. And so the halogen could be fluorine or chlorine or bromine or iodine. You can also have oxygen in your compound, in which case there are different kinds of functional groups with oxygen. Okay, so for example, you can have alcohols that have OH groups, shown here, or ethers where the oxygen is actually sandwiched between two other carbon atoms. Now, here's an example of something with nitrogen in it. Okay, an amine has this NH2 group that's directly bonded to a carbon chain. These last compounds here are sometimes called carbonyl compounds. And so carbonyl compounds contain a carbon double bonded to an oxygen. And there are a few of them that you should know in terms of organic chemistry. Okay, one of them is called an aldehyde. And so attached to the carbonyl group, there's a hydrogen atom over here. Ketones do not have a hydrogen atom, but rather carbons over there, one or more Cs. Then you also have a carboxylic acid, or sometimes called a COO group, okay, COOH. You can see the carbonyl here in the OH group. Here's an ester, where the oxygen is actually bonded to, again, carbon chain. And the last possibility, depending on where you're from, is either pronounced amide or amide or amide. This is where I have a nitrogen directly bonded to the carbon of the carbonyl group.